Welcome to the Walton Pi. Today we are going to be talking about function transformations. So to start off, let's talk about what function transformations are. So these are special types of function composition that allow us to change a function by shifting it, stretching it, and reflecting it. So we're going to go through each of these one at a time. So to start off, let's talk about translations. So translation is a transformation of a function that's going to just slide the graph of the function around. It doesn't stretch it or bend it or anything. It just takes it and slides it around. So if this was our original function before the translation, this might be an example of the function after translation. It's the same shape of the graph, it's just been slid around somewhere else. So we will talk about how we can be able to do that momentarily. So let's suppose that c is some positive constant and y equals f of x is our original function. There are four types of translations. The first one is where we just add a constant c after f of x. So we do y equals f of x plus c. This is going to translate the graph upwards by an amount c. Similarly, we could do f of x minus c, and that's going to translate the graph downwards by c. We could also add and subtract before we apply the function f. So if we do f of quantity x minus c, that's going to translate the graph to the right by c. Now, this might seem a bit backwards to you if you're trying to visualize what this is doing, because if we subtract c, we are moving in the positive x direction, but we'll talk about that in a second. The other one is y equals f of quantity x plus c. This is going to translate the graph in the negative x direction by a distance c. If we rewrite the first two a little bit, it's then going to match the same sort of format of the f of quantity x minus c. It's quantity y minus c. So by subtracting from x, we move it in the positive x direction. From subtracting from y, we move it in the positive y direction. So if you're trying to figure out how this connects and why things seem a bit backwards, let's just ask what would happen if we were to look at where 0 is now. So if we look at y equals, or y minus c equals f of x, well, if we look at f of 0, so we look at what happens if x is 0, there's no change. F of 0 is still f of x. We didn't change anything, so there is not going to be a shift in the x direction. But if we look at 0 equals y minus c, so we look to see when is the y minus c part now 0, we now find y is going to be equal to c. So wherever y used to be 0, now that happens at y equals c, so it's been shifted upwards by a distance c. Similarly, if we look at y plus c, again, there's no change in the x direction because it's still f of just x. So it's not shifted around in the x direction, but if we look at 0 equals y plus c, then we find that y equals minus c. So whenever y equals f of x was 0 before, that now happens at y equals minus c, so the entire graph has been shifted downwards by a distance c. If we were to look at the composition of f of x minus c, this is going to be a little bit different. Here, we're looking to see when f of x used to be f of 0, that's going to be when 0 equals x minus c. So that tells us that x equals c. So wherever x equals 0 used to be, that now happens at x equals c, which is a shift to the right by c. That's why subtracting c from x, that is now saying what used to behave at 0 now is what's happening at a distance c, because f of c minus c, that is 0. So at x equals c, that's now acting like our original origin beforehand. But then if we look at when y is 0, there's no change there, so it's not shifted in the y direction. If we look at f of quantity x plus c, now we can see that the 0 input of f, that happens when x is negative c. And so that's going to be a shift to the left by c. Pardon the typo, but that should be happens at x equals minus c in the very bottom line there. If we look at 0 equals y, there's not going to be a transformation here. So it's still going to be exactly the same in the y direction. So it's only been shifted to the left by c. So, to summarize, these are the 4 ways that we can translate a function. We can also stretch and compress a function. So this is where we take our original function and either squish it shorter or stretch it so it becomes taller, or we could stretch it in the horizontal direction as well. So y equals c times f of x, that's going to stretch the graph vertically by a factor of c. And y equals 1 over c times f of x, that's going to compress the graph vertically by a factor of c. If we look at y equals f of quantity x over c, this is stretching the graph horizontally by a factor of c, and y equals f of cx, that's going to compress the graph horizontally by a factor of c. And just like the last time, we can rewrite these a little bit so it's y over c equals f of x, and c times y equals f of x for our vertical stretching and compressing. Again, these kind of seem a little bit backwards when we write them that way, but if you're struggling to see why these transformations do what they do, ask yourself what happens at 1. So y over c equals f of x, and c times y equals f of x. If we look to see what happened when f of x was 1, we now see that y over c equals 1, so that tells us that y equals c. So originally when y was equal to 1, now y is equal to c. So that's why it's a stretch as opposed to a compression, and then the compression is going to do the same thing, except it sends what used to be a 1 to a 1 over c. So it's now compressed it by a factor of c. And then the same thing will happen if we look at y equals f of x over c. If we look to see what happens when x was 1, that's now happening at x over c equals 1. So that happens when x equals c. So what used to happen at x equals 1 now happens at x equals c. So that's going to be a horizontal stretch. Similarly, a compression is going to be sending what used to be 1 to 1 over c. We can also reflect a function across an axis. Y equals negative f of x, that's going to reflect the graph vertically or across the x-axis, and then y equals f of negative x is going to reflect the graph or across the y-axis. I hope this was helpful in understanding function transformations. Please like and subscribe as it'll help me to continue to make these videos, and please check out some of my other videos. I hope you have a great day and good luck with the rest of your math.